Okay, so continuing on from where we left off, we know that sine of 30 degrees is a half, and we know that sine of 45 degrees is root 2 divided by 2. Let's work out some more functions of sine, right? Well, we said that sine was defined in the range of 0 to 90, so maybe we'd like to know what would happen at either end of these ranges. So what is sine of 0? I'd like to ask that question. So again, I just think about drawing a triangle. Let's go over here, where the angle is approximately 0 that I'm considering. But if you think about what that would look like, it would have to be almost like, I don't know, a straight line. So this angle over here, theta, it's almost 0. Then the opposite side is also almost 0 divided by the hypotenuse. So if I set that up, what I have is sine theta equals O over H. But you know, the opposite side is approximately 0, so this fraction must be approximately 0. So we conclude that sine of 0 is equal to 0. That would be the ratio of the sides in that respect. What about sine of 90 degrees? Well, how would we make that angle 90 degrees? The triangle would have to look a bit like this, right? And you can imagine these lines just shooting off into the sky and meeting somewhere in the distance. But if this is approximately 90 degrees, well, then this is the hypotenuse, this side here, and this is the opposite. In this case, with this right angle triangle, if this angle is approximately, you know, let's say it's 89.9, then they're going to meet at a huge distance away. You can kind of see that. It's basically going to look like a big rotated version of the triangle we just drew, right? Where the bottom of the triangle would be here, right? So this is the bottom. This is the bottom there, right? So that's basically what we have here. And the question is the sine here of like approximately 90. That would be the opposite over the hypotenuse. Well, they're approximately the same, aren't they? They have the same length, just as they would down there. So that gives me that sine of 90 is 1. In a really loose, informal, argumentative sense, we can sort of get out of that sine of 90 is 1. Okay? And you can do all this with cosine as well. And you can see that if we kind of get an idea of what's happening, the sine function starts at the origin, and then it kind of sort of levels off. So by the time you get to 90 degrees, it does something like this. So that's interesting. Now the cosine, however, if you think of what cosine of 0 is, well, remember cosine is adjacent over hypotenuse, and they're approximately the same in this case, so cosine starts in 1. Remember, it's adjacent over hypotenuse. The length of the adjacent is pretty much insignificant compared to this huge length of the hypotenuse. So a over h is approximately 0. Think about a fraction where it's like 1 over 1,337 or something like that. That's basically the scenario we're dealing with here. The hypotenuse is just so much bigger than the adjacent that I can pretty much ignore the fraction. It's too tiny. So cos of 90 is 0, and it ends up doing something like this. So that's the cosine function. But so far, all of this is pretty unsatisfying work. What exactly is sine? What exactly is cosine? You know, they are defined as a ratio of a triangle, and you might know if you've seen more advanced mathematics that you can actually talk about the sine and the cosine of angles outside of the range of 0 to 90. So let's have a proper definition. So I'm going to give you this circular definition. Not circular in a logical sense, but literally because I'm about to draw a circle. And this is a very satisfying definition once you see it for the first time. So I'm going to have a unit circle here. Because it's a unit circle, what that means is the radius of it is 1. So let me draw in on these Cartesian axes where the coordinates would be. Okay. Let's have a point P somewhere on the circle. And let's talk about the angle that it makes with the positive half of the x-axis, which is this bit here. So I'm going to define theta to be the angle that it makes with the positive half of the x-axis. So this point P will have coordinates. What exactly? What are the coordinates of P? Remember that the circle has a unit radius, so this distance is 1. And notice that I have a right angled triangle here. Let's say the coordinates of P were x and y. Let's say I didn't know them. Okay, so this means that this distance would be x and this distance would be y. Sorry, other way around. That distance would be x. This distance would be y. Alright. Now from a previous definition of sine and cosine, we can see that actually y is the sine of theta and x is the cosine of theta. Now that's because if we look at what the sine of the theta is in this case, sine of theta is going to be opposite over hypotenuse. Okay, boom. So y is equal to sine of theta, and similarly cos of theta is adjacent over hypotenuse. So boom, those ones kind of don't really hold any weight in the equation, you know, they just kind of disappear because divided by 1 is, you know, leaves the thing untouched. And we have y is equal to sine theta and x is equal to cosine theta. So those are the coordinates of P. But this is also true, you know, so this holds in this region. So from our previous definition of sine and cosine, when the angle is defined between 0 and 90, this kind of works, right? Well, let me just extend that around. So if theta was, for example, over here, and I drew it all the way over there, I have some angle bigger than 90, maybe it's 110 or something like that. Then let me just define that the new coordinates there are what sine theta and cos theta should take. Okay, so x is cos theta, y is sine theta. So let me just do that again to be really clear. I'm going to have my axis, draw the unit circle on, and I'm going to put a point P at some random location on that unit circle. Let's put it here. Okay, P will have coordinates cos theta, sine theta, where theta is the angle that I've made with the positive half of the real axis. So here theta is about maybe 300 degrees, for example. Then the value of cos theta and the value of sine theta by definition are these coordinates. So a real just word for word definition now. Let's go to that. So cos theta is the x coordinate of a point on the unit circle where the angle it makes with the positive half of the real axis is theta. Cos theta is the x coordinate of that point, right? If someone asks you what is sine theta, what is cos theta, what is sine theta, you're going to say, okay, let me draw you a picture. Boom. The y coordinate of this point that I've drawn here, this point P, is sine theta. That's what sine theta is, right? That's how you work out a value of sine theta. And you're like, okay, I mean, that seems kind of weird to talk about. You know, it seems kind of unintuitive at first. But this is, by definition, this is just what we're defining cos and sine to be, right? So let's explore that a little bit more. We can see that they're periodic, right? We can see that I can actually talk about sine of 370 degrees as well from this definition. Because what happens? Well, what is sine of 370 degrees? I'd need to go 360 all the way around, and then I go an extra 10. So what I've done is I've now gone another 10 degrees, but it's actually just the same as if I just had gone 10 degrees in the first place. So sine 370 is the same as sine of 10. Similarly, I don't know, cos 400, what would that be? Hopefully you guessed it right. It's just cos 40. Because instead of talking about 400 degrees, I could have just gone 40. And, you know, I'm going to get the same x coordinate of that point. Now I can also talk about negative degrees as well. So what would sine of minus 2 degrees be? Well, that would have to be the same as sine of 358 degrees, right? Because I could have gone minus 2 this way, or 358 the whole way around. Okay, the last thing we're going to do is graph these functions here. So if we think about that, again, thinking about the unit circle, look at what the x coordinate's doing. So follow around to me. So currently the x coordinate's at 1, at 90 degrees it's at 0, at 180 degrees it's at minus 1. Now it's back to 0 at 270. And now we make a complete sort of loop there. So let me graph that x coordinate out with time. Let me go to somewhere where I have a bit of space. So That x coordinate, as we've talked about, is our definition of cosine theta. At 0 degrees, we were 1 away. 90 degrees, it was on the y-axis. Then it went down. Then it went back up. Then it went back up. Okay, so if this point's 360 over here, I've got 270. I've got 180 there at -1. I've got a 1 up there. And I've got 90 here. And what we just done is the first graph of cosine theta, right? So cos theta, theta, right? Cos theta against theta, okay? I'm gonna do the same thing for sine and get at that graph as well. So, boom, 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 over here. Let's track sine around. So you can do it with me. Sine of 0 is 0, right? The height of this point is 0 at when it's 0. Then I go all the way up. Sine of 90 is 1. Now sine of 180 must be 0. Sine of 270 must be -1. And all the way back around, and I get sine of 360 0 again. So how does that compare to the cos graph? I can just draw it in the same one. So sine of 0 is 0. And this is a picture we had before. Sine of 90 is 1. Then I go down. Sine of 180 is 0. Sine of 270 is -1. All the way back up here. So it'll loop like that. And you can actually see that I could just extrapolate that section of the curve that I just drew to wherever I want. So sine must look like this. So here's one period of sine. But I'll just do the same thing again. Right, so if this point was 360, then I just, go another 360. I have the same shape. I must do, because I'm just going around the circle again. Similarly, I can go backwards this way to -360. And, all these points should be the same height. All these points should be the same height. It's just the same wave repeating itself. That sine and a cos wave will look similar, right? Cos wave will actually be a bit easier to draw because it's symmetric around the origin. And we can see that, one section of the cosine wave was that. And I do it again. I can do it again over here, right? So where these points are 360, 720, and, -360 as before. That's what we have, okay?